Hi, in this lesson we want to talk about quadratic patterns. So a quadratic pattern is a sequence of numbers in which the second difference between consecutive terms remains constant. So if we were to work out the first difference here, 8 minus 5, we would get 3. 13 minus 8, we would get 5. 20 minus 13, we would get 7. As we can see, this is not a constant difference, but if you pay attention to the definition, it says that the second difference, so the difference of the difference will be constant. 5 minus 3 will give us 2, and 7 minus 5 would give us 2 as well. Now, a quadratic sequence is similar to a quadratic formula in that their general form is very similar. We have Tn is equals to an squared plus bn plus c, where a, b, and c are values that we can solve for. And namely, we solve it as such. We say 2a is equal to 2. Then we say 3a plus b is equal to the first difference. Then lastly, a plus b plus c will give us the first term, and then we solve it from the bottom up. Cool. So if we were to get the general formula for this pattern, first of all, calculating for a would have 2a is equals to 2, and then a is equals to 1. Then calculating b would have 3 multiplied by 1 for a plus b is equals to 3. Taking 3 to the other side, we get 3 minus 3, which gives us 0. Then lastly, a plus b plus c, so 1 plus 0 plus c should equal 5. Then we take 1 to the other side to get c is equals to 5 minus 1, which will be 4. Therefore, we can write our formula, or general formula is Tn is equals to an squared plus, or not a, but n squared plus 0n is just going to be 0, so no need to write that. And then we can just put our plus 4 at the end. So this is our general formula for this specific quadratic pattern. Luckily for quadratic sequences, we don't work with the quadratic series. So that's not something you have to concern yourself with. You should just be aware of the nature of the quadratic sequence, meaning you should understand that the first difference forms an arithmetic pattern. So if you were to ignore the actual pattern, so just for a moment not consider this line, then this would basically be an arithmetic pattern with a constant difference. That's why they are able to ask you certain questions that might require you to find the general form for this difference. We can call it the difference of n is equal to a plus n minus 1d. So you can find the difference between two numbers, and as you can see, this is how they are related. So we have term number 1 here, term number 2 here, term number 3 here, and 4 over here. Term number 1 in the differences will be the difference between 2 and 1. For 2, it will be the difference between 3 and 2. For 3, it will be the difference between 4 and 3. That means for n along this pattern, it will be the difference between n plus 1 and n of the original pattern. So therefore, they can ask you what will be the difference between the 17th term and the 16th term. And then you can use this formula to just get the answer once, especially if you're not given enough information to get the general form of the quadratic pattern itself. So yeah, you should be aware of that dual nature of the quadratic sequence, that yes, it's quadratic, but at the same time it contains elements of linearity. So we have some arithmetic patterns going on. And then lastly, quadratic sequence is similar to a quadratic pattern in the fact that the patterns have minimums and maximums. So it is possible for them to ask you which term in the pattern will have the largest value, or which one will have the minimum value. And you just use the same formula as you would in functions, where we usually use x is equals to minus b over 2a to find the position that has the maximum or minimum. In this case, that would be n, to find the position with the maximum or minimum. And if we can look at this function over here and contrast it with y is equals to x squared plus 4, we can see that this is a function that would look something like this, and it has a minimum, but that's not the minimum it will consider. So b in this case is 0. This one won't necessarily have a minimum, except for when the minimum value will basically be the first value. Since this is a pattern, it's not defined for when n is 0, because 0 is not a position. We start from 1 going onwards. So with this one, the minimum value would be at 1. But that's another nature you also have to be aware of. You need to be aware of the functional nature and the arithmetic nature of a quadratic sequence.